The Earth is around 4.6 billion years old, and for the first billion years, it was extremely volcanically active. These volcanoes released huge amounts of gas, so scientists believe the early atmosphere was mostly carbon dioxide, with very little or no oxygen, rather like the atmospheres of Mars and Venus today. The volcanoes also released water vapor and small amounts of other gases like nitrogen, methane, and ammonia. As the Earth cooled, the water vapor condensed to form the oceans. In the exam, be careful with the wording. We can't be completely certain about the early atmosphere because it was so long ago and there's limited evidence. So scientists use theories and models. The two big points are mostly carbon dioxide and little to no oxygen. How the atmosphere changed. Two main changes turned that early atmosphere into the one that we breathe today. First, oxygen increased. About 2.7 billion years ago, algae and then plants evolved and began photosynthesis, taking in carbon dioxide and releasing oxygen. Over billions of years, this slowly built up enough oxygen for animals to evolve. Second, carbon dioxide decreased. A lot of it dissolved into the newly formed oceans, where it formed carbonate sediments and rocks. Carbon was also locked away inside the bodies of plants and animals, which over millions of years became fossil fuels such as coal, oil, and gas. In the exam, link oxygen rising directly to photosynthesis by algae and plants. Link carbon dioxide falling to it dissolving in oceans, forming sedimentary rocks and being trapped in fossil fuels. Greenhouse gases and climate change. Some gases in the atmosphere are called greenhouse gases because they trap heat and keep the planet warm enough for life. The main ones are carbon dioxide, methane, and water vapor. They work by letting short wavelength energy from the sun pass through to warm the Earth. They also absorb the longer wavelength heat radiation that the Earth gives off and re-radiate some of it back down. Human activities are increasing the amounts of carbon dioxide from burning fossil fuels and deforestation, and methane from farming livestock and landfill sites. This extra greenhouse gas is causing global climate change. In the exam, the consequences to learn include rising global temperatures, melting ice caps and polar ice, rising sea levels and flooding, more extreme weather, and changes to the distribution of wildlife. Always link human activity to the increase in greenhouse gases. Think of it like the greenhouse gases are a duvet around the Earth, and a thicker duvet traps more heat. Carbon footprint. The carbon footprint is the total amount of greenhouse gases, so carbon dioxide and methane, given off over the full life cycle of a product, service, or event. To slow down climate change, we need to reduce these footprints. We can do this by using renewable energy sources instead of fossil fuels, by being more energy efficient, by capturing and storing carbon dioxide before it reaches the atmosphere, and through government actions like taxes or carbon caps on businesses. In the exam, you might be asked why it's difficult to reduce carbon footprints. Good reasons include the high cost, a lack of public willingness to change habits, incomplete scientific information, and the difficulty of making international agreements between countries. Atmospheric pollutants. Burning fuels releases several harmful pollutants into the air. Incomplete combustion produces carbon monoxide, which is a toxic, colourless, odourless gas, and soot, which we also call carbon particulates, which causes breathing problems and global dimming. Most fuels contain small amounts of sulfur, which burns to form sulfur dioxide. At the high temperatures inside engines, nitrogen and oxygen from the air react to form oxides of nitrogen. Both sulfur dioxide and oxides of nitrogen dissolve in clouds to cause acid rain, and both also cause respiratory problems in humans. In the exam, match each pollutant to its problem. Carbon monoxide is toxic, particulates cause global dimming and breathing problems, sulfur dioxide and oxides of nitrogen cause acid rain and respiratory issues.